is the...
Should go with Jack.
Yeah.
Cut one.
So how many people actually looked at the homeworks? No? Like, because we, how many people, like, who did look at the homeworks? You did? Everyone? Oh, cool.
You're good students.
The best class I've ever had.
Sure.
I had just one class, actually. So those were just, most of them were the exercises that we didn't solve in the class. Do you want the I can so, but for the rest, I just, because it's easier, I don't show the PDF. Oh, okay, I can do this on my, still visible or not very visible? So the first few ones are really easy. Can you open the PDF so I don't have to leave this open?
Yes.
Is it possible for you? You can open the PDF. Okay, so I just remove this from here so it's bigger and easier. I did something really bad. Can you help with the... Why don't you... Okay, okay, so where do you want to go? PDF one. Yeah, just put it away. So it's here on the screen that you know. Okay, so if you want, this is exactly. So if you don't want to see this, just do this. Okay. Then you want to see this again. Yeah. Okay. Just put it there. I don't mind.
I think.
Allora, tu vieni alla pausa e tu e tu e tu. Tu l'hai fatto?
Io no.
Non è un esame, quindi lo potete fare da soli, non c'è problema. È solo per dire alla tutto il prossimo corso di statistica per vedere un po' cosa sapete. Ok? Grazie. Grazie.
So the first is just to be familiar with the, for example, if you, is it big enough the fonts or do you see? Okay. So change the line. So this one was just to know that if you divide something by, if you divide a number by 0, it would be inf, which is short for infinity, which is, that's what it is. I mean, if you make minus, it would be minus infinity. These are the only two possibilities. The second one is that if you divide some 0 by 0, it won't be infinity. This is the only exception that gives you nan. If you know math, you know that that should be the case. Those are the main things. And And this one is for power. You have to use this in here. And the last one is, so this exercise was just to practice the basic operations. So pretty easy. Okay. Any question about this, guys? It's a very simple exercise. Okay, the next one, it says that imagine that you have x equals 2, 5, 1, 6. And first add 16 to all of the elements. Everyone familiar with this? So if you add a scalar to a vector, it would be added to every single element. You see, every element is now added by 16. Now the next one says add 3 to just odd index elements. Now, can someone tell how to get the odd index elements? Like with a shortcut, not just to write like 1, 2. I mean, it's pretty short, but can you say the shortcut?
Can you send me the PDF? Yeah, I don't have.
No,
Last
Yeah,
time,
yeah. It has been sent like
No, it
weeks ago.
says last time. It's
No, I
homework.
don't have.
You didn't get it.
No.
Did you get anything from me? In this
Yeah,
last-
I have it. The last email is about video.
This is the homework, and he sent it like, yeah. Okay. I do
Can
it.
you send
Yeah.
from there?
So you didn't do it?
No, last email I got on Feb 3.
Yeah. What's your email? More or less.
MBA.
Double. Anybody else who didn't get the homework a week ago? Okay.
Done.
So does anyone want? Do you know a shortcut for saying odd indexes of a vector?
Just my knowledge.
You just wrote like 1, 3. So if it was like 100 elements, how do you write 100? You want to say 1, 3, 4, 5, 7. How do you? Okay. So you have. I mean, if it was 1,000, 10,000. Hint. Nobody had any idea how to do it? Column. With column, the double. You can use column for indexing, but you have these steps. So if you want to say, for example, 1 to 10 index, you can't write 1 to 10. But if you want to say just, for example, 1, 3, 5, 7, you have to change the step. I don't know if you're... Okay, so one way to do it is to say, for example, here again. So this is x, and you can say 1, 2, and for example, you can say 3. But if it was longer and you didn't know the size, you can also say just end. So it's the same. And so end automatically detects like, I mean, till the last element that you can go with. And if you want to, so you can both read the elements and you can also write the elements. So it works both ways. So if you want to add, for example, some numbers, so what did I ask? I said, for example, add 3 to just odd elements. So we can say something like this. 1 to n plus 3. You see? And the last one is just is everyone clear with the syntax that you have an end? So when you write end, you don't have to. For example, if your vector is has an odd elements or even elements, you have to think like whether. I mean, you might be like thinking what is the length actually. You have to write it. But if you write end, it automatically goes till the last element, which is value with that syntax, with that indexing. So it's a very.
I think some people don't remember what it means to have two numbers separated by colon.
Oh,
It's
okay.
not from one value to the other.
So you have, for example, if you write this,
It's 1 to 10.
did you see what everyone clearly sees what I'm writing? So 1 to 10 is just the consecutive numbers from 1 to 10. If you add another column here, in the column, in the middle, you determine the steps. So if I say 1 to 10, it would go in the steps of 2. So 1, 3, 5. So the difference between these is now 2. Each step. That's called a step. So if I write 3, for example, it would be, now the difference is 3. 1, 4, 7, 10. You see? Now Matlab is smart, so you don't have to worry that this is not exactly the last element. For example, here you see that the last element is 9. So you automatically realize that 10 is actually, so if you go in steps of 2, you would always be odd, and you would never reach 10. But Matlab automatically stops before 10. So it's also nice. And the same thing, so you can use this as an index, obviously. So instead of writing with and, it's easier if you just use this column vector. And it's now clear? I mean, you're happy? The next one, I just said take the sum. I mean, yeah, the sum of the x, which is obviously the sum of x. It's very simple. Okay, and then to practice very basic creation of matrices. So I said that here create a vector day, which is your birthday, like the day of your birthday. So and a month, your month. So it says it should be a vector which its size is 1 by 2.
Yeah, you need to go.
Sorry.
You right click.
Yeah, I
on
know.
If you want to add size. Size the second. It's on the side.
Too big.
You can move them.
So you see so as you notice, if you put comma or space, it automatically creates a horizontal vector. If you want to explicitly, you have to put semicolon to make it. So I mean, you don't have to. And then here. So you see this 1 by 2, 1 by 2, and 1 by 4. It's the size. And then it has to concatenate them. Okay, first check the sizes. You obviously write, for example, size day. So it's the two-dimensional size. By the way, you know that if you want like a size in one specific dimension, you can say, for example, I want the number of rows. So this returns the first one, and this returns the second one, just in case you need it. And if you don't write anything, it returns a vector, which includes the number of like rows or columns or even pages, if it's multidimensional, of the matrix. Here it's just two-dimensional, so it's 2. And the last one is just to concatenate them. So because they're, I mean, you can concatenate it however you want, but if you want to concatenate them as a row vector, because they're already row, and if you want to concatenate them as row, you can either, if you remember, just treat them as numbers. So if you want to make a row vector, a horizontal vector, or row vector actually correctly, and you can either use a space or a column. So here we can just say, for example, day, month, and year. And it's the same as just putting a space.
Comma.
And you can say-
Space or comma?
What?
Comma.
Comma, yeah. Yeah, space or comma is the same. But if you, for example, if you put this, what do you think would be the outcome?
Matrix.
Matrix. Would any
Vector.
better idea? It would be a vector.
Vector.
But
No,
just
no.
keep in mind that these are already row vectors. So
Okay, so yeah, matrix.
what happens? What do you think?
You concatenate
If we concatenate them as a,
No, because that different dimensions.
so you mean it's an error. Actually, it is an error if you see, because this is 1 by 2. So just picture it in your mind. So it's 1 by 2. If you have the first two are actually correct because they're 1 by 2 and 1 by 2. So these two are fine, right? But the third one is 1 by 4, so it doesn't match. And Matlab has this.
It doesn't
policy. No, it doesn't. For concatenation, it doesn't. That's was another. When you add a 0, for example, to some part that doesn't exist, then it adds 0. That was its ending. But for concatenation, you absolutely should check the sizes first. But for example, if what did we do like this? So if you, for example, concatenate these two vertically, so this 2 would be 1 by 2, 1 by 2, so it would be 1 by 4, and this is another 1 by 4. So now they fit. It would be something like this. So just have this like as a picture it in your mind when you're doing this concatenation. Everyone got? Yeah. So the next one. So the next one, again, I don't show PDF because it's hard. The next one was this is not the current directory. It should be somewhere else.
Go to the little arrow on the right. Yeah.
Where?
Yeah. Up. Yeah. That one.
Okay, the previous
Dropbox,
okay,
something,
This,
yeah.
this one?
Well, you want to go to your homework, then
Yeah.
shoot down. Yeah. This one. Yeah. Okay. And now you go on homework.
First one, yeah. Well, no, this is a zip file. Matlab homework.
Oh, the second to last. First, the
Second to last,
Matlab,
okay.
yeah.
So do you know why I had to change the directory? Because if you want to, for example, so these are the files, or I don't have a code, but imagine like you have scripts or files that I want to load, and I want to, for example, say load this data. If you have these names, how is Matlab supposed to know where they are? So if you don't tell Matlab anything, so that's, I mean, I can try. So let's say with this exercise we have peppers. I hope you don't have peppers in your path. So for example, if you go out here, or for example, one of those mat files, it was gdp.mat. So now it doesn't find it because it's not in the current directory. Current directory is what you see here. And as you see, there is nothing called gdp.mat. But if you go inside, there is, and I run the same script exactly, you see now it runs. Now it's just to explain the concept of current directory. But there is another thing. Did you talk about path?
Sure.
Okay, so there's another thing that you have the possibility that to add. So when you have some certain directories that are very important, so you know that you want to access files or codes there, you add them to your path, and this is the path. Sorry, that was completely wrong. How do you say pathfinder? Path. So this is the directories that pretty long, mostly they're for Matlab, but you can also add to them. Anyway, I just wanted to show you why it's important. So
Guys, if you don't remember that, you can go back to the slides, maybe the first or second lesson.
Everybody knows the concept of path? Okay. So if some directory you want to access even when you're not in the directory, you can add it to your path. That's it. Okay, now go back to exercise. We have so I have to load image in read. Oops, I forgot to put the semicolon. This is what happens when you don't put semicolon. So when you're loading something big, you shouldn't ever. So now, if you check, I should clear the other things first. So if you, I hope you see clearly, you have a 300 by 500 by 3 dimensional. The first two are basically the height and the width of your image, and the third is the colors. If you know the RGB, the coloring of this is RGB image. So if you say just show, this is the command to show the image, it would be it's here. Yeah. So maybe you can dot it so you can compare, or I don't know. Just, so for the first question, I say you can copy this into another image, right? So you make an exact copy, it's exactly the same. But now, just to see what happens, we, for example, set the second and third page, which is the green and blue, to 0. So let's see what happens. First of all, give me a minute. It's exactly like the way we index the one-dimensional vector. So we have image 2. You want to say all rows, all columns, but just the second and third page. So this will be the syntax. Is everybody what? Okay, go. If you have some problems, just if you had a question, just ask. Okay, so this is the result because we set the other columns to 0. The next one I said copy it again to another matrix, and then this time set the first row to 100th row. 0, and then show it again. Sorry, I put. What did I do? That was non-capital. I wanted to. This is. So now let's see. As you see here, it's like the first 100 rows in the image are 0. The next thing I have to copy it again into another one and then use flip. So flip up down. So if we save it again, it would be.
Good. IM instead of ING.
So now you see flip. This is a nice way to see how the functions of Matlab works. So flip up down is exactly flipping the picture, and flip left right. You can also see here. If we now do the flip left right, and then show it again. And if you remember, it's actually flip from left to right. So it's a cardiac here. That's it. Do you have any questions about these functions? I think it's a very nice way to look at this matrix. Image is a nice way to illustrate this, dimensions, third dimension, for example. So I have to do that. You sure you don't have questions? Okay. The next one is about normality. That, for example, we can check it with the car big data set. So there is a function histFit, which shows the histogram and the normal fit, so you can see if the distribution is normal or not. So we say histFit, for example, our acceleration. So it seems kind of, visually to be normal. So now we can try with weight. Now again, it seems that it's just visual, we don't have any number or quantitative measure, but it seems it's not very normal. There's another function which is probably a more quantitative or maybe shows in a nicer way. That's called known plot. It's, this one shows you the data and let's see. So if you say, for example, the same thing, acceleration. So you see that the concept basically is that if it's normal, it would be the data points would be mostly close to the line, which here they are. But if they're not, then they will be diverged from the. So the second one that it didn't seem very normal now, it doesn't seem normal also here. Let's see. If you have questions, no one? Okay. Where is it? So correlations. This one. So again, the same data set, and the only point is that if you compute a correlation between something that is an and, some vector that has not a number value, the whole correlation. So, for example, if we say like 4 horsepower and you can also say horsepower and what? Wait for some. So you see it's NAND. Why? And as you see, between the first and second one and between the first and first one is NAND. So this one is not. If we add a third one, by the way, if you have a
the data set was another one, I think, small. What? Not careful.
or small. Oh, sorry. Yeah, you're right. It's just the same. It's a subset of this. Yeah, you're right. Let me change it here. Low, more. That's just a smaller example of the same data set. So, again, if we compute the correlation, it would be not a number because there's a single value. You can actually check here horsepower. There should be here something somewhere. Okay, it's a little big. There is some now, definitely. Now, I actually found that this value that this is a single value. So if we set it to a number, which here I just randomly chose 0. Oh, H. What happens? It's really busy with something. Come on, let's see that it works.
Each pair of columns in the n by
So
two matrix X congruent matrix
it should.
X and matrix.
Command and C is the stop, right? Or Control and C.
Control C.
Control C.
Ah, bravo. What did you do?
And this instead of horsepower, I'll use H.
Oh.
It doesn't stop.
Ah,
I don't know what happened. Really. So I just wanted to write horsepower here. So now if you make the correlation, now it won't be not a number. So that's something that, so if you had something in your correlation matrix, then there's probably something wrong with the data. And if you want several variables, you can just add to the columns. For example, let's say, what do we have? Cylinders. We have maybe the double thing for acceleration. So yeah, for example, you can see that there is a positive between the first row and column. So this is the first and second one. Horsepower and weight have a positive correlation. That's probably because your cars have horsepower. First and third one, horsepower and cylinder, which again makes sense. Horsepower and acceleration, okay, it doesn't matter. But if you want, so these are the correlation values, but you don't know still if they are significant or not. This is a Spearman correlation, so it's a linear Spearman correlation, and if you want the p-values, you can just...
This is Pearson, I think, right?
Pearson, sorry, not Spearman, Pearson. So if you add another output to the... If you add another output, a second output, first one would be the same matrix. So the first one would be the matrix that you get before, and the second one is the p-values, which here is all significant. So you can see that all these correlations are actually significant. It's so small that it's showing them as 0, but they're probably not 0. Any questions? Do you have, you know why does it give like this? So if you have a matrix as an input, it would look at the different columns as separate variables and then compute. So if you have, for example, n columns, it would output the n by n matrix. The number of rows is the number of samples that you have, basically.
Or you remember that in the diagonal, these ones just should not take them into consideration.
I mean, it's basically saying that you are looking at the same variable in itself, which doesn't mean anything. So the next one was the 2-sample t-test, and okay. So I say the location data set. We have a hypothesis that says that this measure of arc, which is diastolic, it's called diastolic, the variable. Sorry, here. So this variable is a measure of blood pressure, I think, and the hypothesis, the null hypothesis, says that I hope that you're familiar with null hypothesis, and you are. So you have a null hypothesis that says that for smokers and non-smokers, this blood pressure thing is the same. So that's something we're trying to falsify. How do you falsify it? This is the... So first, you have to have two vectors. So one for non-smokers and one for smokers for this diastolic measure. What you can have is that, for example, you can say alcoholic, and if you say smoker, this is a logical indexing. It will return the value for a smoker. If you want to say for non-smokers, where is the...
Oh, Alt and N.
No, it's not.
Alt and N.
No.
And like no. Alt and well, because how you change
Yeah,
to
it's
American. See it somewhere? This one. Yeah, this is the end. It's high. Why don't you just change it for a minute to Swiss?
You can also change that. This is all over.
No.
Yeah.
And now I change it
I
back.
could, yeah. But I just copy this variable, hoping that I don't need to copy anything else. So if you... So with this tilde, you negate the logical, and then you have the non-smokers. And so with these two vectors that you created, you can now do a t-test, which is simply t-test 2. Now what we had, sorry. Yes. Smoker. Oh, now it's so this is a basically it tells you that if the value was rejected or not. So again, this function has two outputs. The first one is called edge, which is I think basically comparing the value of the p-value to 5% if you haven't changed the default, and it returns 1 if it's less than 5% and it returns 0 if it's more than 5%. If you want the p-value itself, you have to look at the second output. So here is extremely small, which basically means that they are different. So the null hypothesis likelihood is something to the minus of 17, which is almost 0. Yeah. T-test 2 means that these two, I think, can be a different size. I guess. Anyway. And if you want to change the p-value default, I think this is the syntax that you have to use. Yeah. So if you want to change the default p-value, you can, or you can just directly compare this number to whatever you want. Question? So next one is for plotting, and it's again with the patient's data. Now, now we have a cell screen, which is either male or female. It's called gender. Do you have gender? Yes, here. So we have the cell screen, which is male or female. But what we want is that we want to transform this into a logical array, because we want to use it as an index to say like we want male or we want female. So how do you make it? If you remember, we used str compare. So to take a string and then compare each of them to a single thing. So now we have we can say, okay, let's call the variable, for example, male, which is a logical array, and we say str compare gender to now a string male. So this would be a 0 and 1 matrix. Basically, 0 is for female and 1 is for male. You can see like male, male, female, female, male, male, female. So it's correct. Now that we have this logical array, we can use it for plotting what I asked. So we have a weight and height, and we want to plot it separately. So a scatter plot for weight and height, but separately for men and women. So you have a different marker and different color. Okay, so let's first plot it for example, male. It would be height. Now, logical indexing, we can say male, weight, male. And if you want to determine the marker, for example, if you want blue with the, I don't know what I said, blue with star. This B means blue, star is the marker. So, here. So, now if you plot the next one, it would erase this first one. Do you remember how to, if you didn't want to erase the first one? You remember? Hold. Okay. So it's hold. And now we do the same, but now with the opposite. So again, now we want to change the marker. So change marker and color. For example, let's plot this with the crosses and red. So now you see that it nicely it's different. It's obviously because. And yeah, if you want to add title and other things, you can, for example, say x label, for example, height, y label, weight, title, yeah, you can add as many things as you want, or you can just edit it with the graphical interface. You can add legend, by the way, if you want, for example, to say red is male, blue female. You can say male, female. So now you have the legend here. And that's it.
So for the legend, it's the order in which you...
Yeah, the order that you plotted them. So we first plotted the male and then plotted the female. First plotted the blue and then the red. So we said male and female, and then first it's male goes to blue and then it goes to red. Any questions? And ANOVA, analysis. Oh, I have this one. Okay. We have, for analysis of variance, we have popcorn data. And so popcorn, let's see here first. Popcorn is basically just a matrix that. So these are different brands, and we want to check if different brands have different yields of producing popcorn, which I think is the volume, I don't know why. And one way we can do it is that we can simply say popcorn. So it will create very fancy results, which are telling us this is like the mean, I guess, and these are the variances. and you can see that it's very different, I mean, visually, or you can also look at the p-value, which is also very small, so it means that different brands have different views. Yeah. So actually, I honestly don't know what exactly these other numbers, each of them means, but you can find it out.
Sum of squares, degrees of freedom,
Okay.
mean squares, the f value, which is the square t value basically.
Okay.
Well, no, maybe that's only true for when comparing two things, two groups.
So you have, so the different, another thing is that the rows here also have another meaning. So the first 3 rows are for air, like the popcorn is produced with air.
Oh.
The and the second, third row, like from 4 to 6 one are with oil. And that apparently also has a difference, makes a difference. So you want to analyze it based on the both factors. Then now you can basically say 1 or 2, and first you give the matrix, and then you say like how many repetitions there are in. So we have 3 and 3, so we say 3 here, and again it gives us the. So this is the p-value for the, again the same thing. If the factor 1 is important, the second one is if factor 2 is important, which both are, so apparently have both brand and the way to produce has an influence. And the third one is if the factor 1 and factor 2 are correlated, which is not, so it's good. Is that?
No, if they interact.
Yeah, if they interact, that's, so it's good that it's, if they were interacting, maybe that would have been like a byte for that. Is that, yeah, like, no, it doesn't matter. Okay, it's just showing. I don't know exactly how you can interpret it.
Well, an interaction would be that certain brands
yeah,
produce more with oil and
exactly.
other brands more
Yeah,
with
yeah.
air.
So they don't. This p-value, which is big, means that they don't interact. The brand and the so the first factor and second factor don't interact. Any questions? Yes.
If there is an interaction, how to do post-hoc comparisons with Matlab?
Oh, that's for statistic class, I think.
Well, you can. I actually don't know because I don't do that in Matlab, but you could, for example, if there's only 3 levels, you could go and do t-tests, and then you have to divide your alpha by the number of tests you do. So if you have an alpha of 0.05 and you do 2 tests, then you divide it by 2, 0.025, etc. So then you have to correct basically the number of tests. But that's a very conservative correction, not for only. So there are other corrections. Yeah. So I don't know, do you do
Well,
post-hoc
I use
tests on?
I usually use information theory measures, so that's like you have the given this if you have more information, but
Okay.
that's different. So
Well, if you want, we can look for next class in terms of post-hoc tests.
I don't know.
Maybe
how
there is
to-
a function.
So you mean if there is for interaction, how to like?
Yeah, something like post-hoc.
Right. So you have to say like you want to ask if there is interaction. How can you confidently say that it's not because of the first interaction? It's like purely because of the second factor. That's the question.
No. If there's an interaction, what drives interaction? Like maybe the difference between oil and air only applies to the first and second brand, and the third brand, doesn't matter.
Okay. I don't know. But in terms of like syntax and other things are clear. The functions. I mean, but this is everything that you have to ask. You can always look up the. It's a very, very big help that Matlab has. So you can press F1 and look at the help. And it has several examples, so maybe this thing that you say is actually here discussed, I don't know. which I thought that many people would actually like to know better. So importing data in Matlab is very convenient from Excel or from spreadsheets. And here, for example, we have this data US economy. So the nice thing is that, did you watch the video that I sent? You didn't. Nobody did. You know how much time? It just, there are different ways to import the matrix. To import the spreadsheet. The first one is importing every column as a separate variable. So you have a variable called date, GDP, unemployment, oil, and a date. So this will be imported separately. If we import them as a numeric matrix, as you see now it's changed to this, so it would be imported as a single numeric matrix. Have you tried this before, or this is the first time you hear this? You have tried. Okay. Who else has tried importing different ways? But nobody has tried. Okay, so I explained it briefly. It's very useful because when you're dealing, this gives you a lot of flexibility how to import the data. So you have a column vector, which if I click import, you see that there are separate variables, and they are exactly with the length of the number of rows. So every column turned into a variable. Now if I clear here, and I click it again. Now if I change it to numeric matrix and import, it would be a single variable, which is 119 by 4. So it's imported as a single matrix, which many times it might be useful because you don't want to have several, if it's like 10 columns, you don't want to import them separately. And this one it's good if you have strings. So if you have a string, you can't import them as basically because they don't have a fixed length each element, so you have to import as a string. This last one is very, very nice if you have a 2014 or 15. It imports them. So the reason it's very nice, and it is because you can import different columns as different types of variables. If you look, you have something written underneath the names, which is for all of these guys is number. But you can actually, I don't know why you can't. What is the version for this laptop? I don't know, maybe it's something, so it should have, we will see later, maybe this data set is not, this spreadsheet is not very good, but, so there's number, string, cell, and date, and logical. So here, we unfortunately don't have anything apart from cell. So, yeah. And another thing that you might need is that if there is an empty cell, how to import it. So if here it says that replace unimportable cells, you can import it with not a number or whatever that you wish. You can put 0, for example. We will leave it at that. Okay, so let's go back to this. It says import them as separate columns. Oh, by the way, there's just one thing else that you can change the range that you import this. Okay? Just like Matlab. Just like Excel itself. So now we import them as separate column vectors, and then we plot each of the GDP, oil, and unemployment in separate variables, in separate plots. So for example, we make a subplot 2 to 1. Here I plot, for example, unemployment. Now we can say subplot 2 GDP and subplot 3 can say price of oil. So this is this number of rows, number of columns, and then you go like this, like a spiral. So first, second, third, and blah, blah. And another interesting thing is to look at the correlation between these values, if unemployment is, for example, related, which we want to look at with the help of core plot. It's very convenient to use. So you have, you just write a core plot. Shows you very nicely the scatter plots, how they, for example, that shows the linear regression, like how do you say, linear, the line that fits them, the linear regression line that fits them, and the histograms. So you see that all of them actually have positive correlation. Do you have questions? So next one we have it's the last one.
So should we finish the exercises then do a short break? I think we're almost finished, right?
Yeah, it's the last one.
Is that okay? Yeah. Okay.
The last one is it asks. So now we practice a little bit with the importing thing that I said. First, load Republican CSV as a single matrix. So we have this matrix, which this is also nice because you can also see that this variable is now date time. So you import it exactly as a date time. But for that case, you have to import it as a table. But here we don't want to import it as a table, so we import it as a numeric matrix. And we don't include the names because they're not numbers. Now we click import. Just let me remove this other guys. And now it says for the first 10. So this is basically over time, and so the rows are time, and the top 10 rows are basically the top most recent numbers. So what I ask is to compute the mean for each row, the mean for each column for the first 10 rows. So it would be mean of the matrix, but not for all the matrix, for the first 10 rows, and for all the columns. So this would be, this would be the mean for the first 10 rows, and this would be the standard deviation for the first 10 rows. And we can plot them using error bar. So mean of
That's a colon instead of semicolon. Stop. Now at the end, the last bracket there. Yeah.
and this is also that's great. Yeah. These are NaN because some of the polling are missing for the yeah. Because it was sorted according to the which candidate is actually oops. Yeah. The next one is import the second this democracy.csv. Now let's clear again what we did. And this time we import this guys as separate variables, so our column vectors. This is again date time. So now we can plot, for example, date as X variable and, for example, Clinton as a Y variable. And just remember that you have to put them as a marker. It's very small. Let's see. If it's a bit bigger. Oh, it's a bit bigger. Yeah. And you can hold this plot and plot the second one in red and circle, for example, which is like this. It's nice. And the funny thing is that when the type of the X variable is as a date, it actually really shows the name of the month and blah blah. So if you have a variable date, it automatically the plot function plots it very nicely. Yeah, I think that's about it.
Okay. So, what about I just present you in 5 minutes or maybe in 2 minutes the exercise, send you the file, and then you're free to go and have a break, and whenever you want, come back and work on it. Yeah? Facciamo così?
Yeah.
Wait, the other thing with the fragments, we should another time.
Can you show me?
Yeah, sure, we're gonna have this in a minute.
Okay. So, I sent you these 3 slides together with an Excel file per email right now. Here I explain the exercise, and it's actually something which I do whenever I create a new experiment. So, at least for people who do stuff which is similar to what I do, so create experiments where you show different stimuli to people, but it could be also to rats, and you want to make sure that you show them in a semi-random order, okay? And you want a new semi-random order for every participant. Well, this is useful. So basically, imagine there are 2 researchers, and they want to present 36 stimuli by repeating them. So each condition, there are 3 conditions. It's not working. There are 3 conditions, and each condition contains 36 stimuli. The total is 108. The names of the conditions are A, B, and C. Okay? And what I call conditions are actually blocks of 3 trials or 3 stimuli. It's the same. So for each of these conditions, A, B, and C, there are 12 blocks. Because 12 times 3 is 36. We want these blocks of 3 trials to follow each other in the final list of trials in a random order. But actually it's not totally random, because we never want more than 2 blocks of the same type to follow each other. So we can have AAB, but never AAAB. Clear? Why? Because otherwise, for example, participants get really bored and then it changes the results. Moreover, in each of these blocks, A, B, and C, or these conditions, we want another semi-random order. So we don't want the first block of A to be similar to or the same as the first block of B. We want them to be random. So that's an example of how the final list would look for one subject. So we will have 4 columns, and we'll have to do this. In the first column, you have the trial number, the second column we have this condition, A, B, or C. And here you see the first block, which contains 3 trials, and the second block. They are both of the condition C. But then it switches to A. Why? Because we want to make sure that there's never more than 2 blocks of the same type following each other. In the third column, you have the stimulus. So for you guys, it's not important, but these are pictures. And in the third column, I created a vector which determines the duration of the stimulus in seconds. And as I will explain in a second, these are random durations between 1.5 and 2.5 seconds. So the mean duration is 2 seconds. So how should you do this? First, you load that file that I sent you, the Excel file. You should have gotten it in the email. And to load it, you use XLS read. Yeah? If you don't know how it works, you type help XLS read. Then we need a big for loop. So this is to practice for loops. Why do we need a big for loop? Because we want to do this not only for 1 participant, we want to do it for 10 participants. Then inside of that for loop, we create first a vector called block order. That's going to tell us, if there's A or B or C and in which order they're going to follow. And in there, we want 12 A's, 12 B's, and 12 C's. And then we need to randomize it, this order. You can use, for example, rand per. So I'm giving you already help, right? They're giving you the functions, basically. But then we want to check that there's never more than 2 conditions of the same type after each other. Never more than 2 AA. How do we do this? Well, we use a while loop. And if the check fails, then the while loop continues going. You remember, while loops, they never end until something becomes true or something becomes false, depending on how you define it. Okay, so once we've done this, we want 3 different random orders for A, B, and C. Again, you can use rand per. Then we start creating our final trial list with underscore, which will contain 108 stimuli because it's 36 times 3. And how are we going to do this? Well, in our vector called block order, it tells us, the first 3 trials are actually the block A. So I need to go to my rand A, which I created, the random order of A, and I need to take out the first 3. Then block order tells me, then the second block is actually C. And, okay, then I go to rand C and I take the first 3, etc. So it's kind of tough, but I think you can do it. And this is just, this is kind of on top of that to add this duration and add the trial number. This is actually pretty simple. Here you can check out the function in space. You concatenate everything because these are going to be columns, just need to concatenate them horizontally. And then you need to save it. Now if you're working on a PC, you're lucky. You can use XLS write. Really simple, you can check it out. However, I want you to save it with the name or the number of that subject in the name of the file. So one example here, I'm concatenating the script, the text, which is list underscore sub underscore, and here I'm adding sub. Why? Because sub is actually the name I give to my counter for the big for loop. So the for loop that goes for the 10 subjects, I said for sub equals 1 to 10. So sub is going to be 1 at the first iteration, 2 at the second iteration. So basically, for each subject, it's going to change me the number, and that's very handy because then I have the number of that subject in the name of the file. So that's easy. If you work on the Mac, it's actually not so easy. So you could, the simple way is just save it as .mat, Matlab file. Or you can try fprintf, which works for both Mac and PC very well. It's kind of more complex. Questions? Okay, so then whoever wants takes a break, like me, I have to go pee, and you can start working on it whenever you want.